Is it sine? Is it cosine? What do you mean you don't know? It's sine? It's sine. Because sine goes through the origin, 0, 0. And then cosine of 0 is 1, so it has a peak at the y-axis for cosine. Right? Okay. No, don't tell me sure. Tell me that you know. All right. Anywhere you see that it hits the sinusoidal axis and going upward, that's a slope of 1. Do you see that, guys? So wherever you have that, let's plot a point. We're going to plot the derivative curve. I'm going to use blue to plot the derivative curve. So here it is. That's a slope of 1 there. So I'm going to use blue, plot a point on 1. Same x value. So plot a point on 1. Plot a point on 1. Okay. Wherever you see horizontal tangents, look, I have a horizontal tangent there, horizontal tangent there, horizontal tangent here, horizontal tangent there. What's the slope of a horizontal line? 0. So wherever you see blue is my derivative of that line, of that point. Try to make it perfect. Okay. Wherever you see green, I have slopes of -1. That's a slope of -1. That's a slope of -1. And it looks like that's the only one. So wherever you see blue again, I'm plotting the slope. I'm plotting my derivative. So go to -1 and put a point. Hold on, guys. Let me get some water. No, not water. Coffee. All right. What do those blue points look like? What do those blue points look like, guys?
Cosine?
Yeah. It looks like cosine. Look at that. I have a feeling some of you guys already knew what the derivative of sine was. Who cheated? Who told you? Did someone tell you? Tell me the truth. Did someone tell you guys? How did you know, Mazuka?
Because it looks like cosine.
Okay. All right. I believe you. All right. So we can make the following statement. It is exactly cosine. The derivative of sine x is cosine. The most common mistake I see people do this all the time. Do not tell me that sine x equals cosine x. Sine x does not equal cosine x. If you tell me that sine x equals cosine x, that's only true when x is pi over 4. And I guess if you want to be technical, it's true again at 3 pi over 4. But don't tell me that sine x equals cosine x. The derivative of sine x is cosine x. Do we understand that, guys? So proper notation is key. All right. Now I wasn't planning to do a proof. Oh, don't look at that yet. Well, I guess. Take a guess. What do you think the derivative of cosine is? You're close. It's almost sine. It's negative sine. I wasn't planning to do a proof, but I don't want you guys to be robots and just literally memorizing these things would be robotic. They come from somewhere. So I want to go ahead and derive at least one of them. Since we already did this one with graphs, which is, by the way, this is not an official proof, right? But we kind of already did it with a graph. So you can see that the derivative of sine x is cosine x. So I want to do this one with limits. So I'm going to say f of x is cosine x. So now I can say this. I want to know what f prime of x is. So by the way, I'm doing something different here. So look, there's my line. I'm going to call this proof of der for cosine x. Don't write der, you guys write derivative. Because you might look at your notes later on down the line and be like, what the heck is dir? Hey, don't be mad. Oh, that was a yawn? I can't tell. Your yawn and your mad face look the same. Because you go like this, and then well, you go like that, that's also the same as mad, you know? All right, so here we go. Limit as h approaches 0 of cosine x plus h minus cosine x all over h. And obviously, you're going to have to do something with that cosine x plus h. So side note, cosine a plus b from pre-cal is cosine a cosine b minus sine a sine b. So coming back to this one, I'm going to replace that. So I'm going to write, you guys see now that I made it bigger? F prime of x limit as h approaches 0, and I'm just going to expand this right here, what's over here. Cosine x, cosine h, minus sine x, sine h, minus cosine x, all over h. So now, guys, I'm just going to rearrange some of these. So I'm going to rearrange it. Limit as h approaches 0. And I'm going to write cosine x, cosine h minus cosine x minus sine x, sine h. All this is still over h. I'm going to factor out a cosine x from these first two. Here's how I'm going to write it. I'm going to write this as two separate limits. Limit as h approaches 0, cosine x factored out, cosine h minus 1. All this is over h, minus limit as h approaches 0, sine x, sine h, all over h. And don't worry, guys, it looks complicated, but it's not. So look at all this. This is not an h, this is an x. I'm going to move that right there. So I'm going to write cosine x, limit, because it's not being affected, because it's an x, not an h. Limit as h approaches 0, cosine h minus 1 over h, minus, that's the same thing there, sine x, limit, h approaches 0, sine h over h. Finally, I get to an answer. This right here, limit as h approaches 0 of cosine h minus 1 over h, that right there, guys, is just 0. Because it's cosine h minus 1 over h. Now, what about this one? What about sine h over h? That's a 1, because it's approaching 0. H is approaching 0. So, all this shebang is just negative sine x. What? All that just for that? Okay, so what do I mean? So if I have a function that's cosine x, the derivative of that is just negative sine x. And there's your proof. Yay. Don't worry, we'll catch you up because don't try to write all this because it might be too much. How do we feel right now, guys? All right, here it is. Can you be a robot and just remember these? Yes. Do I want you to be a robot? No. Did we just derive, so tell me right now, you guys, I want to hear you guys in the background say yes. Did we just derive the proof, not the official proof, of how the derivative of sine x is cosine x with graphs? Yeah, we just did it. You saw this. We did it with a graph, guys. Did we just make a proof? We just did this one from scratch for how we get the derivative of cosine x that is negative sine x. Yes, and no more sad face, no more mad faces. Okay, well stop it. Next one's the merit. All right. So now that you know, are you going to be doing that every time just to get the derivative of cosine and sine? No, just remember, derivative of cosine is negative sine. The derivative of sine is cosine. Because I was about to tell you guys a trick. That's why I paused. I was going to tell you guys a trick on how to remember the derivative of cosine is negative. Should I just tell you the trick right now? Yeah. All right. If I'm taking the derivative of any trig function, virtual, guys, if it starts with the letter C, it's going to be negative. Well, the real reason why is because of this. Because if you do the limit expansion, see that minus there? So that minus turns it into a negative. The derivative of any negative trig function that starts with letter C is going to be negative. All right, let's see if we can do some problems. Example 1, or problem 1. Find the derivative of the following functions. So I'm finding dy dx. So here we go. I write dy dx equals vx squared is the first, the sine x is the second. So my product rule, first times derivative of the second. What's the derivative of sine x? Cosine x. Plus second times derivative of the first. Chavez, I don't like that way. I like Khan Academy's better. All right, well then do Khan Academy's way. It's okay. Khan Academy switches up their variables. They do, instead of saying d dx of uv equals uv prime plus vu prime, they do, yeah, they do v u prime plus uv prime. Is that how Delta Math does it? It's because Delta Math is Common Core. Losers. No, it's not wrong, it's right. You know why they do it this way? Because the quotient rule is this, but with instead of a plus, it's a minus, all divided by bottom squared. They do it that way because it's easier to remember for when you're doing quotient, and they'll never mess up. But this is the way most textbooks have it. Unless they're like high school textbooks want to dumb it down. Now, I'm not saying that one is dumber than the other, I promise that. I'm gonna have to edit that. Okay, edit, remind me. All right, letter B. I'm taking the derivative of u with respect to x. That's it, that's your derivative. What rule do I have to use for letter B? Yeah, what is it called? Starts with a Q. Quotient rule. That's a U. So how do you tell the world that you're taking a derivative of u with respect to x? Du dx, perfect. Du dx equals, so let's sing the song. Low d high, so 1 minus sine x, d high, so that means derivative of the top. What's the derivative of cosine x? Negative sine x, put it in parentheses or else it looks like you're subtracting, minus high d low, cosine x, d low, so derivative of the bottom, derivative of 1 is 0, the derivative of negative sine x has to be negative cosine x because of the negative in the front, all over low, low, 1 minus sine x squared. This one, you're going to continue if it can simplify. On Delta Math, I think in the beginning, they don't care. They just want to know if you can do it. But so on Delta Math, you can probably type it like that and it'll be correct. But let's simplify it. Distribute. 1 plus sine squared x. Negative times a negative is a positive. So write plus cosine squared x over 1 minus sine x. Oh, guys, and I'm missing, there's something, yeah. It's not a 1. That should be a what? Yep. There it is. Now it's 100% correct. Have I lost anyone out there, guys? People? Mazuka, did I lose you?
There should be a square at the bottom, right?
There we go. I did that on purpose, guys. No, I didn't. I didn't do it on purpose. All right, next. What is sine squared plus cosine squared? That's 1. Negative sine x plus 1 over 1 minus sine x square on it. Does there look like there's something that I can do here? It looks funky. Yeah, guys, look, rewrite the top. I can cancel out one of them. This is like 1. So my final answer how do we feel? Okay. All right, again, there is a formula for how to just remember the derivative of tan x, but we're going to derive it. d dx, excuse me, tan x is the same as what over what? Okay. What rule do I got to use to take the derivative of that? The quotient rule. Bottom times the derivative of the top. The derivative of sine x is cosine x plus or minus? Minus top times the derivative of the bottom. What's the derivative of cosine? Perfect. All over what? Cosine squared x. I could have put it in parentheses, but I decided to put the square after the s. There it is. Let's expand this. Cosine times cosine, that's cosine squared x. Plus, because negative times the negative is a positive. Sine times sine, that is sine squared x. All over cosine squared x. Okay, what's cosine squared plus sine squared? 1 over cosine squared. Okay, what's 1 over cosine squared? It's equivalent to what? It's a reciprocal trig.
Secant.
Secant squared. Are you going to be doing all this over and over again just to get the derivative of tan? No. So next time someone tells you, what's the derivative of tan? You're going to say secant squared. Do we understand that, guys? All right. I don't know why I put so much space. I could have probably put another problem down there. All right. We're not going to do the proofs of all of them. These are easy to remember. The derivative of tan is secant squared. The derivative of cotangent is negative cosecant squared, using the same process. The derivative of secant x is secant x tan x. The derivative of cosecant x is negative cosecant x cotangent x. Yes, you can use the same process to find those as well. You can call secant x 1 over cosine x, and then if you want, you can use quotient rule for that, and you'll get secant x tan x. Do you guys want to see that, or are you guys just happy to just know it? Okay. Let's see that. Look, all this white space, you're just gonna what? No, it's not a lot of memorizing. I'm gonna show you a trick. Huh? Is it a song? We can make it into a song, maybe. Well, it's, okay, maybe, we'll see. Do you guys agree that secant x is 1 over cosine x? All right, let's do quotient rule with this. Bottom, cosine x, times derivative of the top. What's the derivative of a constant? 0. Minus top, 1, times derivative of the bottom. What's the derivative of cosine x? Uh-oh. Yes. Negative sine x, not bad. All over cosine squared x. Okay, look at this. This guy goes away, right? So now I have this. Negative times the negative is a. So I have sine x over cosine squared x. So I'm going to expand it now. So let's see. I'm going to write it like this, guys. 1 over cosine x times, because I want it to look like the answer that you see, sine x cosine x. That's the cosine. What's 1 over cosine? Secant. What's sine x over cosine x? Look at that. Are you going to be doing this over and over again to get the derivative of secant x? No. All right, there's an easy way to remember. The only two you have to remember are these two. Or the only ones. What's the derivative of tan? What's the derivative of secant x? Yes, the secant x is the one that has secant x itself. You got to demerit. That's like a record. 4 times in the last. Did you get sleep? Okay. All right. So Chavez, this is you guys. Chavez, what do you mean you just got to memorize those two? I don't get you. I don't understand. You know what? I'm getting tired of you, and I'm getting tired of this class. All right, stop. You're getting overboard. Here's how you do it. Look at tan, and it'd be easier if you were here, guys, because you could see me pointing at my board, but you can't see me because, okay. Anyway, look at tan. Tan is secant squared. So whatever you're not using has to be for the cotangent. So cotangent, what's the derivative of cotangent? Well, I already used secant squared. I'll talk about the other one. It's either secant or cosecant. That's it. So the other one must be cosecant squared. Now remember, anything that starts with the letter C has to be negative. So there's a negative. Look at secant. I use secant x tan x. Okay, what about use cosecant? Well, this has to be the other ones that I'm not using. So it has to be cosecant x, cotangent x. Yeah, and all the c's when they take the derivative are negative. Do you see that? So it's really simple to remember, guys. Look how simple it is to remember. Secant x is secant x tan x. Cosecant x, it's the same as secant x, but it's cosecant x cotangent x. Look how similar they are. Secant, cosecant. So cosecant, cosecant, cotangent. If the secant is secant x tan x, then the cosecant x has to be itself with a tan, with a cotangent, sorry. Because I already used the tan with the secant one. Does that make sense? Yeah, it could be a tongue twister, I guess. I could see that. But they're easy to memorize. You don't need to use a lot of brain processing power to memorize these. You don't. They're easy to remember. Look, you guys already remember. Okay. Find the equation for the lines that are tangent and normal to the graph. All right. The only way you can do this question is with a calculator, because they give you an x value of 2. I should have taken this one out. I've done a different problem. But oh well, we already have it. So I'm going to show you guys how to do it with a calculator. First, get a point. Plug in a 2. F of 2 equals tan 2 over 2. And see what that is. I have my calculator in radian mode, I believe. Nope, it wasn't degree mode. Let me change it to radian. And now that I'm in radian mode, I'm just going to type in tan 2. Always in radian mode. Everything in calculus is radian. And I get a negative 1.092519932. We don't care about all the decimals, but we at least need to have 3 digits after the decimal. Minimum, all time, unless specified otherwise. So I have my point, 2 comma negative 1.092. And yes, you can say 92 or you can say 93. Rounded or truncated would both be fine. Next, I need a slope. How do I get my slope? From the derivative. I have to use what rule for this one? Quotient. Bottom times the derivative of the top. The derivative of tan is perfect. Minus top times the derivative of the bottom. All over bottom squared. I'm going to plug in a 2. Chavez, I don't have a TI-84 that tells me how to get secant squared in there. Well, sorry, you suck. No, I'm kidding, guys. You don't. Cosine squared with a 2 in it. All right, let's see what that is. I'm going to take my TI-84. Oh, you know what? Let's go to Desmos. Desmos does it. I actually found out that there's a button here. Desmos has secant squared, but I already put cosine, so too bad. Cosine of 2, and all this is being squared. There, secant squared. I could have put the square in the bottom, but I decided to put it in the top. Minus or plus? Minus what? Tan of 2. I'm going to show you guys something that's going to blow you guys away. Well, maybe, I don't know. And then on the bottom, what do I have? 4. Okay, here's my slope. Oh, put an equal sign there. There's my slope. What is that? Write that number down, guys. Okay, so what do we get? What was this number again? 3.433. So here's my tangent. Y minus or plus now 1.092 equals 3.433 x minus 2. I would not bother. I would leave it alone right there. Tangent. It also wants the normal. You know what? We're going to plot these because we already have it on Desmos. I didn't close the Desmos, did I? No, I didn't. Perfect. Normal. Y plus 1.092 equals 1 over 3.433. Oh, negative, yeah. X minus 2. There's my normal. All right, I'm gonna go back to Desmos. And don't worry, I'm gonna share this time. I'm gonna clear this. No, actually, I don't want to clear that because I have my derivative graph in there. Wait, do I have my derivative graph in there? No. There you go. It's in green. So the green graph is my derivative graph. And I'm going to type in my two equations that I just got. So y, I already forgot the numbers. What was it? 1.092. Actually, I don't need the derivative. I just need the original. Okay, 1.092 equals 3.433. X minus 2. It wasn't x minus 1? Oh, it was x minus 2. Yeah, you're right. Check it out, guys. Yeah, that definitely looks like a tangent at x equals 2. Perfect. Let's do the other one. Y plus 1.092 equals, and then I'm just going to say the lazy route, 1 divided by 3.433, and the negative in the front. I did it again. Negative. And then scroll, x minus 2. And there it is. Chavez, that doesn't look perpendicular. Well, that's because the window is not square. Let me square it. We did, well, okay, it doesn't matter. Well, actually, it does look perpendicular. But there it is. Cool, right? Desmos. Okay. This one wants, what does that y prime prime mean? Okay, let's do that. Y prime, what's the derivative of secant x? There you go. See how easy it was? Now, to take the second derivative, what rule do I got to use now? Product. Y prime prime equals first, secant x, times derivative of the second. What's the derivative of tan x? Secant squared x, plus second tan x, times derivative of the first. What's the derivative of secant x again? Secant x tan x. All right, now just make it pretty. So this is going to be secant cube x plus, and there's 2 tans on that one, so I'm going to write secant x tan squared x. If you wanted to factor out a secant x, you can, but I would leave it alone. What do you guys think?